You can do that quietly, that would be very good. These word problems, we did word problems about putting things together that we call combining. Today we talk about word problems that talk about separating, which means we're actually taking things apart, making them into two different whatever things. You know, we had 15 marbles, you're separating the red and blue or whatever they are. And these, ladies and gentlemen, the pattern of these is subtraction. But I've told you this before. Please understand this. Just because something has a subtraction pattern does not mean that you use subtraction to solve it, which goes back to this. This ugly incident that we just talked about right here. Notice this was a subtraction pattern problem, but actually to solve it we had to add. So you got to get in your head that you have to figure out which of the things you need to do. Now let me give you the pattern. It's a simple little pattern and it makes sense here. When you have subtracting, when you're talking about a story problem, something real in life, like let's say I started with, how many fifth graders are there?
22.
Is there 22 fifth graders? Yeah. Okay. I start with 22 fifth graders. I take away the girls. How many are left? Here is the pattern that you use. You have some go away, and then it's how many here you have what are left. By the way, the answer to a subtraction problem is called the
difference.
Yep, it is. It is the difference. It's the answer to a subtraction problem. Just like sum is the answer to an addition problem, difference is the answer to a subtraction problem. Now, here is what our first little problem here. Let's do this. After losing 234 pounds, yeah, new precision, 234 pounds, comma, Jumbo the elephant still weighed. Jumbo the elephant, we'll just call him Fant because I don't want to write that whole word out. Jumbo the Fant weighed 4,368 pounds. Weighed 4,368 pounds. 368 pounds. How much did he weigh to start? How much did he weigh to start? Write that problem down, then we're going to talk about it just momentarily. This is a sum and some went away problem because he started at some weight. He lost some weight. When you lose something, it goes away. And he had an ending weight, what was left. And you need to plug that into our pattern. And again, just because it maybe is going to be a subtraction pattern, does that mean we subtract? Not necessarily. Now, let's look at what we have here. This is kind of his sum weight. This is kind of like the starting weight. This is how much weight went away, and this is what he weighs at the end. Which of those do I know? Do I know what his starting weight was?
No.
I don't. So that's where we put the little letter. We'll put the letter W. I don't know his starting weight. Let me move that over here. But I do know when I subtract, how much weight did he lose?
234.
He lost 234 lbs. And then he ended up being 4,000, God bless you, 368 pounds. So this ladies and gentlemen, believe it or not, as a teacher, this to me is, God bless you again, one of the most important things that you can catch on this. Now, how do I solve this? Caleb's going to say, well, first you think of an easy problem because I don't want to get mixed up because I know I'm either going to add or subtract this thing. So Caleb, give me an easy problem. Stay away from, by the way, 2s and 4s. Just because 2s and 4s, simply because 2 times 2 is 4 and 2 added together is 4. So I always stay away from the 2s and 4s because they can mess you up when you're doing this. So anything but 2s and 4s and 1s probably. Any subtraction problem that doesn't have 2s and 4s. 12 minus 6 is 6. Alright. If I don't know, see I don't know the top here, I don't know the top here, what do I do with 2 6s to get 12? I add them. So that's what I'm going to do here. I'm going to take 4, 3, 6, 8 and add 234 to it. Get my 0. 4,602 pounds was the weight of good old jumbo banter there. And I know some of you think that's an awful long way to get whatever we need to get, but that's just the way it is. One more story problem here. Boom, boom, let's do this one. 400 runners started the race. 400 runners started the race. 400. Like a lot of time. We only have like 300. But only 293 finished. Uh-oh, what happened to that? Could be one of those 100-mile races that people race.
And die.
I don't think too many died. How many runners dropped out? How many dropped out? So if I am looking for, the pattern of this, again, I'm not so concerned about what answer you get as to what the pattern is. This you have to recognize as separating. It's because you have the runners that started, you're separating the ones that finished from the ones that didn't finish. So if we're looking at our pattern here, we have the racers we started with. We're going to take away, what are we taking away? The ones that dropped out. And then we end up with the ones that finito. Finito. So which of those 3 do I know? Do I know how many started?
Yes.
How many did start?
400.
There's my 400. Do I know how many dropped out?
No.
So what letter am I going to use? Let's use a D.
A G.
Oh, we use a D because it stands for dropped out. Or you could use R for runners. It doesn't matter. Do I know how many finished?
Yes. 293.
And then because I don't know for sure if I add or subtract to get my answer, we go back and think of a simple problem. And it doesn't have to, you can use the same one every time. Let's do the 12 minus 6 is 6 thing. If I'm missing the middle number in this, what do I do with 12 and 6 to get 6? No, 12 plus 6 is not. You subtract. So in this case, you actually have to subtract. 3, 9, and 10. 107. 107 is how many dropped. So hopefully you can kind of see that and enjoy that.
That was awesome.
Wasn't that exciting?
That was exciting.
Oh yeah. Oh my gosh.